Sometimes equations are a little bit messier or have a lot more steps. And I wanted to review the basic strategy for such equations. But other equations you might encounter might have a lot more stuff in them. And a general rule of thumb, or kind of a general strategy, is at the top of this next section of the packet. And I think it's a helpful way to approach them if you're not really sure what to do in such equations. But usually what you want to do is you want to simplify both sides of the equation so that you have just a series of terms. Like this equation is, I would say it's kind of expanded, or it's simplified in a way that you can't really do anything. Because on the left-hand side, we have 5y plus 4. Remember, those you can't add because they are not like terms. When you have a number and you're adding to 5 times y, we can't add those together because what this reads is 5 times something plus 4. Well, if I don't know the something, I can't add it together because the order of operations teaches us that we must multiply before we add. So it's kind of like we're stuck over here. Same with over here. But what we still can do is we can apply the additive property of equality to still solve this, even when it's a little bit harder. So usually the first step is to simplify either side when possible. In this particular case, it is. Step 2 says to put all variable terms on one side and all constant terms on the other side. And so the variable terms are just the terms that, and the word term we just use for the things which are separated by addition and subtraction within an equation. So we'd say like this is one term, this is another term. On the left-hand side of the equation, this is a term and another term on the right-hand side. And the equal sign is always separating those two sides into separate algebraic expressions. An algebraic expression is different from an equation. An expression just is something without an equal sign, where an equation has an equal sign. But basically, and when I say put them, you're not allowed to just move them. Like, so the implication is that it's always using that property. So for example, on the left-hand side, I have 5y, and the right-hand side, I have 3y. My goal would be to put them both together. And you could do that either way. You could either subtract 5y from both sides, or you could subtract 3y from both sides. And you might be wondering, why am I subtracting? Because there's no plus sign in front of it. But since it is a positive amount, if I want to get rid of or delete a positive amount, the only way to do that would be by subtracting it or adding a negative version of it. And so we really have choice. We have choices when we're solving an equation, but I would always subtract the smaller, or in this case, when it's positive. When it's negative, you want to subtract the larger negative. But let's start kind of simpler. I would want to subtract the 3y. And I'll explain why that's the case as we go. But basically, if I were to subtract 3y from both sides, 3y minus 3y would make 0, because anything subtracted from itself cancels by because they're additive inverses. And on the left-hand side, we have 5y minus 3y, and since those are like terms, they would combine, and we'd add or subtract the coefficients in this case. 5 minus 3 would leave me with 2y. And that's another rule of elementary algebra, which if you don't really remember why that makes sense, we can go over that in lab. Or if you're feeling like really lost, I'm guessing probably most of you are not. But if you are, I'm always happy to go over anything, even basic, during office hours or when we meet. But basically, I wanted to explain why I'm subtracting the 3y instead of the 5y. It's just because if I subtract 5y onto the right-hand side, I would have 3y minus 5y, which would leave me with negative 2y. And it's usually easier to, we usually want to keep it positive, so that it's not, we're not introducing more negatives. So that's why I would always say, when it comes to the variable terms, subtract the smaller one. And once I've put all the variables on one side, so I kind of view that as, moving at the left-hand side. Though it's not just moving, right? I always have to do the same thing to both sides of the equation. And I'm still left with plus 4 on the left-hand side. So, what we could do is just rewrite the equation like this after completing that action on both sides. But I'm still not quite done because I still have more steps. So I have 2y plus 4 equals 6. But the other thing is I also want to put all the constant terms on the other side. So in the same way, I wanted to, if I'm putting all the variables on the left side, I want to put all the non-variables on the other side. So since I have plus 4, the only way to get rid of that would be by subtracting 4 from both sides. And you know, I could do, usually what I would do is I would do those both at the same time, just to save energy. And that would leave me with 2y is equal to 2. And after I finish doing that, right, so I put all the variables on the left-hand side, all the numbers on the right-hand side, or constants. Now, I'm still not done because I have 2y, and so I still need to divide both sides by 2 to cancel out the coefficient. And the coefficient is just the word for anything attached to a variable term. So, you know, again, I'm trying to not use too many big words that, you know, and review what those mean. But again, this is all elementary algebra stuff. But, you know, for a lot of you guys, it might have been a while since you've had algebra. So I don't want to skip too much. But if I divide both sides by 2, that would leave me with y is equal to 1, the final answer. And I could make sure that that makes sense by plugging it back in. So I'd have 5 times 1 plus 4 is 9. 3 times 1 plus 6 is 9. It sure makes sense. And when I plug it back in, it should be the same on both sides, as is the whole point, right? We're trying to figure out what is the answer, what is the solution to such an equation. And also, but sometimes, like with step 1, it says simplify either step when possible. Like a lot of times, like say for example, looking at the example directly below it, 3t plus 1 is equal to 18. Sometimes we might have something where we can actually do math first. Like in this case, 3 times t plus 1, we could use the distributive property to multiply this out. 3t plus 3, because remember that when you have a parentheses, that means that the whole thing is multiplied, in this case, by 3, because that's what the parentheses indicates. And we can always multiply our 3 to each individual term, which would leave us with 3t plus 3 on the left-hand side is equal to 18. And I don't have to do anything to the right side because the right side is already simplified. So we're not doing things to both sides yet just because we didn't want to. And then afterwards, I could put all the variable. Well, there's only one variable term, so that's nice. But there's a constant term on both sides, so I'd want to subtract that from both sides, and that would leave me with 3t is equal to 15, and then I could divide by 3, leaving me with 5, our answer. But in this example brings up another point, is a lot of times there's more than one way to solve an equation. And like in this particular case, I could have, sorry, I'm trying to erase this real quick. I could have actually started by dividing by 3. Because since I had 3 times this whole thing, I could just divide by 3 to cancel it, and that makes it a little simpler by removing that division to begin with. So that would leave me with t plus 1 is equal to 5. And that's really easy because from there I could just subtract, 18 divided by 3 is not 5, 18 divided by 3 is 6. I was getting one step ahead in my head. And so if I divide by 3 first, that would just leave me with only t plus 1, and the parentheses would disappear because they wouldn't be needed anymore because there wouldn't be that 3 to multiply to anymore. And then I could subtract 1 from both sides, leaving me with t is equal to 5. But this is another important point about equations, is that no matter how you solve them, you should get the same answer regardless. So notice, I got 5 over here. If your friend is solving a problem differently than you and they're getting a different answer, that means that somebody's got to be wrong because it's got to have the same answer. That's the point of an equation. Now, sometimes equations can have different answers, but not equations like this, not simple linear equations.